issue about common questions, FAQs. We're going to obviously provide you with a copy of the slides, video recording, and I think Britta has started recording. Have you started recording, Britta? Thank you very much. Excellent. So there you're all organized, getting lots of queries. Excellent. And obviously there's a certificate of attendance. For those who want to have a certificate, we'll give you that at the end, a little thing that you can do, get your certificate of attendance if you want it. My name is Steve McKay, and I had to come to South Africa. I'm based in Western Australia for the last 40 years. I'm the Dean of the college, for what it's worth, and I'm a mechanical, electrical, and chemical engineer. Basically, industrial automation has been my focus, and I learn something new every day. But I'm here for a few days at our Joburg office, our new office here. Actually, I was quite impressed. We've got a new office we're moving into from there because the number of students is skyrocketing. I suppose for obvious reasons. Obviously, lots of people are interested in engineering, so it's really fantastic to be here. Got some personal tragedies to deal with, so that'll be next after this visit. And I love learning, so that's my background. I started off in diamond mining many years ago. In fact, we're interviewing a lecturer here today, and she's also worked in the diamond mining industry, which is good. And then I moved on to oil and gas in building a platform of the Northwest Shelf of Western Australia, which is a very big project, and then did quite a few constructions of power stations, gas turbines, Mars turbines, and basically a focus on automation. And for the last 30 years, I've been doing consulting work and working as a dean and teaching one of the subjects in electrical engineering at the bachelor level. So that's my background. I learn something new every day. Thanks, Chris. So just a quick review of what we're doing. This is not a sales spiel for EIT, but just to give you a bit of background where the materials came from. What they call a dual sector provider. So we've got vocational courses, advanced diplomas, and degrees, and we've got about 4,000 students from 160 countries around the world. So it's really fabulous to have you guys here. South Africa is growing dramatically, and there's a lot of other reasons to get an Australian degree than just qualify, and a lot of people are exploiting that for obvious reasons. I can't disclose why it's useful to get an Australian qualification, but we are focused on job outcomes, and nothing infuriates me more than having a useless qualification with no industry focus. And we're definitely not perfect, but we do try and have an industry bias. What was most embarrassing for me, hello, welcome. What was most embarrassing to me was doing a 4-year degree in engineering a long time ago. And then when I started with De Beers, they said, mate, chuck it all in the bin. We'll start teaching you. And I said, well, I want to do some software design and electronic design. No, mate, you're going to strip that D9 bulldozer now. So I was a bit distraught by that, but it was actually, as it turned out, it was really fortuitous. It taught me a lot about degrees and diplomas. And then we've also got micro-credentials, and we've also got to focus on online. And whether we like it or not, and it's a bit distressing for me, having come from a traditional background, but the online model is the way to go. So we have a live interactive model, and we have labs, which you log into, because again, whether we like it or not, everything today is connected through your phone or your computer. So it's all internet connected. And that's where we go for. And we also run quite a lot of conferences in the UK and Australia and Canada, and in fact South Africa as well. And we've focused on global partnerships. So what we're doing now is accredited with the Australian government for our diplomas and our degrees, and we're now going through accreditation process in the UK for degrees and the US as well. So that's it. And in South Africa, we're having a little tangle with the South African government trying to get some of our bachelor degrees accredited, but unbeknownst to them, the horse has bolted. Basically, everyone's going for online degrees, and that's probably one of the biggest focus. There's always a bit of concern, and certainly for me, there's a huge concern with online engineering degrees. You say, well, mate, how can you do an online degree? And it's a very valid question. But of course, today, everything is changing to online, and everything you do is connected via the internet or through the Internet of Things to your equipment. So it's starting to make a lot more sense. But despite that, we still insist on practical hands-on experiences as well. And we've got some students here. Oh, thanks. Sorry, I keep forgetting. Britta, thank you very much. We've got some students here today that are doing some hands-on stuff because they haven't got the necessary hands-on experiences. But I would say that most of our students that are mature age have far more lab experience, hands-on, than any academic at a university. So, you know, we're well ahead there. So we're confident in our model. And then obviously the other thing we do is we have student support, and probably one of the most important things is our learning support officers, and they support the students. And that again is a departure. We ran a big session for TUT about a few months ago showing our model, saying academics should be able to focus on teaching because they're often incompetent about supporting students, and you should then have paraprofessionals to support the students. That's our model. And they thought it was a good idea, but of course, it's quite slow to get that implemented with the universities. And yeah, obviously, as I said, we focus on physical, remote, and virtual labs. One of the biggest changes happening, and you can see it very clearly, is that the simulations are so realistic today online that they're often more realistic than the practical equipment that you deal with. So there's a big change happening there as well. And but we still insist on practical experiences. So if you don't have a hands-on experience, you can't graduate. So that's quite a critical part of our qualification. The I suppose one of the comments is student survey. We get surveyed by the Australian government every year through a quilt, and we came top of all the universities in engineering, not in social sciences, engineering, for quality of the entire educational experience. So we try very hard, and some years we bump up, some years we bump down, but we're near the top most of the time, and that's our focus, obviously. The excuse me, the agenda is laid out here, and I'll try and follow it. We've got one of our IT gurus, or our programmers. We thought we'd bring the programmer in rather than the top dog. We've got a programmer called Nika who's going to demonstrate something. So I may just twist the agenda a little bit. But basically what we want to do is just talk about what the objective today is, what artificial intelligence is, and I see there's quite a few people here who know quite a lot about it, probably a lot more than I do, maybe, hopefully. And then I just want to talk about AI versus machine learning, then AI and chat GPT, and then demonstrations of AI at EIT. So I'm going to bring that one forward. So Nika, wherever you are, if you're listening to me, I will call on you very, very soon. I know you want to go to sleep, but if you can hang on another half an hour, which is another part of the world. And then case studies, I just want to do the case studies with you guys, where we, as I said, we break up into 4 groups with computers orchestrated by Lamlo there. Lamlo, have you got all the computers ready? Thank you very much. And all the support ready? Thank you very much. Thank you. And then a wrap up at the end. So that's basically what we want to do today. So really exploring about artificial intelligence and machine learning. As I overheard someone at the back saying, look, mate, this artificial intelligence is a load of, you know, it's just a basic whole bunch of data stored there. And don't get too upset about it. And it's true. Don't get too agitated by it today. But it is important that you see what is going on. So you know you have the tools to work through the developments over the next 10 years. And I would suspect, and I could be wrong, but I suspect that what you'll see with AI is the classical model of lots of hype, the valley of death, make this AI is complete crap, and then eventually the build up again. And I think we'll see this, and I think we're around about here at the moment. So we will see that play out. But despite that, it's really worthwhile understanding because the tools can be valuable. But as an engineer, you are not going to use AI or ChatGPT or any one of the other tools to control your caustic soda tanks or your pressurization or anything critical. You're going to be really, really careful about it. So we've obviously got to realize those sort of problems. I'm going to talk about power and water when we talk about the applications, and then we'll break you up into groups, and then we'll obviously hopefully you can try the various scenarios. And I've got a few scenarios with power and water, and I want you then to try out with ChatGPT what's going on. Now, I need to go through some of the theory, and Nico, thank you so much for listening to me for the moment, but hang in there, we will be with you very, very soon. Now, the question is, why is it worth worrying about AI? Now, this slide is very difficult to read, but I've taken it from University of Leeds promotional poster, and it's a little bit difficult to read, so I'm going to just read out the critical things, but basically, address challenges in your area. It's obviously worthwhile getting into the area. So various things are network and experts around the world, enhance your employability, be at the forefront. So the universities give you the usual stuff, but ultimately it is really, really important to be aware of AI and start working out the tools that are appearing in the marketplace, because this can enhance your job seriously. And obviously, ultimately, it will enhance your remuneration, your pay rate, whether you're a plumber or a professor of medicine, it will impact on your life. And it will make things a lot easier. Now, obviously the biggest issue is we're always faced with great opportunities, and obviously discusses insoluble problems. So they obviously have a lot of problems, but I think we've got some huge opportunities coming up. So the question is, what is AI and what is machine learning? Now, when I started getting into machine learning, it was quite amazing. I was thinking about, I did a course at UCT in 1983, and there we had machine learning. We had the beginnings. It wasn't called machine learning. It was basically big data. Hi, welcome. Sorry about the space. You can take a seat there, and there's a seat there. Sorry about that. Oh, gracious. Thanks. Sorry, guys. Those seats there. Thanks so much. So I started the machine learning with a wonderful professor from the Toll University who was actually at Dartmouth College. And we were analyzing texts. So it was a business degree, but we're analyzing text using a very rudimentary computer. But very powerful techniques were emerging, like fingerprinting and stuff like that. But obviously, it took another 30 years before anyone started getting into it. So really, the over-encompassing thing is artificial intelligence. Then machine learning is a subset of artificial intelligence. And then the other thing I want to focus on is deep learning. So the deep learning is basically, you could say, almost like a subsidiary of machine learning, but I like to think about them as separate. The machine learning is the more brutal statistics, multivariate statistics, as I used to call it. And the deep learning is when you use neural networks. Neural networks is probably the wrong descriptor because it hasn't got too much connection to our brains, but we'd like to think it does, but it is considerably different. And obviously, with all this technology, and I'm going to go through some of the theory, but very, very cursorily, because at the end of the day, it's all blah, blah, blah. So the trick is to focus on the main points, which is application, which is what I would like to look at. So let's have a look at the next slide. And just to introduce it, so machine learning basics is obviously a scientific field. Machine learning is when you have a training process, so you do training of the data. And those of you who are familiar with ChatGPT will know that it has had significant training, stolen, and I'll use the word fairly confidently, they've stolen all the internet, the largesse on the internet, and they've trained a model. And I think legally it's going to play out in a very awkward way in the future. So one's got to be very, very careful about your ownership of anything you develop from it. And then obviously you use the training to take your labeled data and then make predictions. And obviously you've got some very basic stuff and analyzing data, and it's basically a very simple, often a statistical model. Brother or sister, let's use you to actually start classifying my data out there. So training and then classification. Now, when we do the exercises, we've had everything trained. And then you're going to try and use the model to do some predictions. So there's basically three forms of machine learning. And as I said, machine learning I regard as a more brutal form of AI, where you've got basically two main categories, supervised and unsupervised. And then, as you would aware of, there's a gaming thing called reinforcement learning. So supervised is email classification. So if you want to classify emails as good or bad or trash or spam, you'd probably use a supervised model. Very straightforward. And then you also have a unsupervised model where you're looking for patterns in data, and then you, like a witch doctor or Sangoma does, they throw the bones on the ground and then they look at the patterns formed. That's exactly what unsupervised learning is, if I can be brutally simplistic. Supervised learning, as I said, you could regard it as which happens with your email every day, or one of the exercises I love doing is classifying leaves of plants. So you go and classify the leaves in a particular way, the type of plant, and then you can then classify, you train up the model with the different leaves of the different botanical plants, and then you can put a leaf in front of your model and then it'll tell you, oh, that's the blah, blah, blah plant. So obviously a very straightforward supervised model. And then reinforcement learning, we're not going to worry too much about here. And then some examples of supervised learning are logistic regression, classifiers, linear classifiers. You hear things such as naive Bayes. So there's a lot of buzzwords there. I'm not going to worry too much about them, but it's a very straightforward, structured form of analysis of your data. The unsupervised version is a little bit more random, I suppose, but the one that I've had some very happy times writing Python code for, because Python is a very powerful language to use with machine learning, is clustering. So K means clustering, which basically looks at the distance between each of the items that you're trying to classify. So you actually have a thing called K means clustering. So basically you're trying to let the model create the patterns. And an example is, I'll come to in a tick, but just want to mention one thing here. Principal component analysis also sounds really, really complex, but you know, one of the most amazing things I did in 1984, was we took shopper data, people going into a shopping center. And if you visualize going to a shopping center, obviously every shop wants to maximize their sales. So what you do is you take all the different parameters that will maximize your sales, like the way you present your goods, the type of goods. And so you can actually put a little descriptor next to each of those, and you can interview the shoppers, and then you can actually create a little matrix, and you can then do an analysis. And again, using big data. So again, it's a very effective way of analyzing. And nearest neighbor classifier, again, is, as I said, trying to let the data sort itself out, and then you can actually take a new test example. It'll actually form patterns, again, unsupervised. So I'm just skimming over the top of these things just to give you a bit of a view of what's going on. And then obviously deep learning is the next part. So we've got machine learning and deep learning. And deep learning is the basis of the ChatGPT model, as you would know. And that's what obviously we're going to be using in a tick. So I just want to look at the theory behind deep learning very, very briefly again, so that you can just. So the issue with deep learning is you create a layers of points and you connect them together, and you've got data coming in, input coming in here. And I'll give you an example. A classical example is a analysis of digits 0 to 9. And the idea is that you then use these layers to actually sort the data out and actually tell you whether the digits are 0 or a 1 or 2 or a 9, because you've written it in your hand script, and your handwriting is often very clumsy, and it will then classify the digit as a 0 or 1 or 2. And again, using deep learning to do it. So deep learning is probably pushed machine learning aside to a considerable extent with solving a lot of really, really difficult problems. So deep learning, very effective at learning patterns. So the typical example is vision, I suppose. And it's trying to show you again with deep learning that you can actually, the first layer of analysis gives you, you're looking at this picture there, gives you a very superficial view. As you penetrate the model, the layers, you get more and more aggressively to the actual vision. Now, vision is a tried and tested view of deep learning, but most people won't be using that. And certainly we're not going to be using it in examples today, but it's quite a satisfying solution, looking at deep learning to come up with solutions. But we're going to look at natural language processing and various other applications using deep learning. And obviously ChatGPT is built around deep learning rather than machine learning on its own. I don't know why that's all messed up like that.
So maybe sometimes we could think it's a buffering of data. We can end up with images like this.
Thank you very much. Buffering of data, absolutely. So that's a real mess. I don't know why it's done that. Anyway, what we're trying to show you here is that deep learning, if you look at this little shape here, these boundaries here, very complex. Machine learning would have great difficulty distinguishing between those different animals. So you've got the yellow and then you've got the blue. And deep learning can actually create a model which can actually distinguish between those. So the point we're trying to show you with that diagram is deep learning is a solution. And the most common example of neural networks or deep learning is obviously handwritten analysis. So if you look at this here, it's a 2. But in fact, you've got 256 pixels here, 1, 2, 3, 4, 5, all the way to 256. So you want to feed 256 pixels into a box, a black box. And out of it, you want to feed 0 to 9. And if you try and get a traditional machine learning, supervised or unsupervised, to do that, it's very difficult. But if you use deep learning, the solution is fairly tried and tested. So every one of these little pixels is a element. So you get a thing, the classical diagram is the layers, which I'll look at now. You can just swap to the next one. Thanks, Britta. So we've got 256 inputs. So as an engineer, you know there's 256 inputs, and we've got 10 outputs, 0, and then 1 to 9. So you want this box here to actually work out from this information that's given to it, come up with a pretty well 99.99% guarantee of the right digit. So for 2, it must activate only 1 output. So the question is, how do we do this? And of course, the obvious solution is we use deep learning to come up with a solution. Machine learning cannot do this very easily, but deep learning can. So the the model is the classical, this saga here, and again, I don't want to get too bent out of shape, but here we've got inputs. They go through what they call a weighting factor. So you get the pixels coming in here, 256. They go through a weighting matrix, weighting line. They get added up to a bias, just a number, and then you feed it out there and you feed out through the output. Then you feed it to another layer and another layer and another layer, etc. So the idea is that eventually you get the 0 to 9 as an output. And the idea is that the weighting factors and the different layers have to be trained, and there's a whole methodology of training your neural network, which we won't go into here, but the idea is that that training will then create a trained neural network, which then can detect 0 to 9 with various pixels and come up with a guaranteed answer. So that's deep learning. And that is the basis of the large neural network models. So we're going to be looking at that for the ChatGPT. So before I do that, I just want to give an example, and that's where I want to get my colleague in the Philippines. Is she awake still? Excellent.
Yes, I do.
Can she talk loudly on here? That's the question. So we want Nico to talk loudly for everyone to hear. Will that be possible?
Can you hear me?
We just want to give her a thing. So is Nika there? Excellent. Nika. So Nika is a programmer who's put together a model which we're starting to experiment with, which is to support students. So basically, you still have a lecturer, but you have an AI animal or chatbot which can actually interact. And we've been working on this for the last year, and I've just got a 2-3 minute demonstration. We've just got her up. She's a bit late at night, her time, but we want to get her just to give a quick demonstration. Hopefully she can come online and we can give a demonstration.
Hi everyone, I hope you can hear me well.
Is she around?
Hello, can you hear me?
Okay, so we just want to get the microphone up, and then so what she's got to do is share her screen.
Hi everyone, I hope you can hear me well and see the screen over here. Hello?
Thanks, Damla. Okay, good. Good, thanks.
Hello, are we all good now?
Well, while we're waiting, I'll just quickly introduce ChatGPT. And obviously, the focus of the exercise today will be using ChatGPT. And obviously, the idea is that it's going to make a big difference to life. And most of you probably have worked with ChatGPT, so it's probably fairly the idea is with ChatGPT is obviously if you are not able to check the accuracy of the output from ChatGPT, Yep, sorry. Yep. Okay. Obviously, the internet's been a bit problematic here. Forgive me for the, we were trying to show the chat bot, but just to give you a bit of a reason for why we're talking about the AI. As I said with ChatGPT, make sure whenever you use this tool that you actually can check it in some way with a real human. Otherwise, you will be very disappointed if you're looking for 100% reliability. It's not anywhere near there. Oh. Okay, good. Thanks. Thanks very much, Leva. Okay, so obviously there's a few issues which I'll talk about later. The legal ownership. You can imagine a AI, artificial intelligence model that's gone through and cleaned up the whole internet and extracted all the data from that. There's going to be a lot of unhappy people with data which has been used by this model for training purposes. And of course, there's a few questions as who owns this data. And obviously, it's owned by the individuals. How they're going to enforce their rights is obviously a topic for the future. But if you do use any of these tools, be very wary about the ownership of the data because it's not very clearly defined. So I'm sure there's going to be a saga about that in due course. So ChatGPT, as you would be aware, it's good for summarizing text. You can remember previous discussions, so you can get a session going, chat away, saves time and money. But bear in mind, obviously, it's trained on data up to September 2021. So what that does cause some issues as far as recent data. And there's a potential bias in the data as well. Obviously, when you've got massive conspiracy theories and all sorts of other interesting stuff on the internet, and you've trained your AI model on all this data, it's hardly going to be a very safe model to use. And it will be biased. And presumably it'll have the usual racial biases and various countries, which is obviously a problem when you're interpreting the data. So we've got that to worry about, and that can be a huge safety hazard for your business, for us as well as a college. And obviously, when you're using the ChatGPT, just bear in mind the exercise you do, you can only have one topic on it at a time. You can't try and load it up with multiple issues at the same time. And obviously, the magic word they always use is hallucinations, and the model can hallucinate. It can get a bit confused. And obviously, the one which is always quoted is that lawyer in New York that was in a court case recently and who used ChatGPT to go and look up for cases. And of course, a lot of the cases were made up, the references were made up by ChatGPT. So it didn't end very well for him. So the formula that you'll be using is when you're using ChatGPT, for those that are not familiar with it, you're going to say, if you want, for example, I'm going to give you a road design topic to design with. and I'm going to say, I want you to work out the layout, the road, and there'll be other ones with a pump station, and I want you then to come up with a solution. So you'll tell ChatGPT, hello, brother, you are a top construction engineer, or you're a top control instrumentation engineer, or you're a top plumber, or the best in the world, and I want you to design the following system. So then you put in requirement 1, 2, 3, 4. Be very, very specific. Any wordy, long words won't go down very well. You will get results which are not good. And it's often worthwhile using recursion, as I say, which is ask ChatGPT to say, print out the results as I'm going through them. In other words, report on what it's thinking as it's going through the solution. So those are all good solutions. And there's also a boundary set, which you can say, don't go here, or don't do this, or ignore this issue. You can also do that at the end. The other suggestions which are coming up are forgive the internet here, it's been a bit sluggish today. Be detailed and specific. Try and include all the necessary information. If you want a specific result, try and specify the length of the result. I want you to give me 200 words on blah, blah, blah. So actually specify what you want from it. Don't be, try and use correct grammar. So if you use spelling errors and things like that, it doesn't end up well. Don't be ambiguous, be concise. And if you really want really good results, like you're classifying data from a town or something like that, why not give it examples? Hey, this is what I've done. I've done the first one for you. I've done the first solution for you. This is what the results are. Use that to do your other outputs. And then you can also have a system level boundary, which is to say, has specific constraints. I don't know why the internet, the PowerPoints are messed up here, but don't worry about it. But basically put in specific constraints as well at the end. Don't do this, don't do that. But as I said, that's probably secondary. And then recursion, as I said before, is really to give step-by-step reasoning. So as some of you will be aware, if you give this ChatGPT or any of these large language models, as we call them, if you give them a numerical problem to solve, it often gets it wrong. So if you say 3.5 times 10.5, it may give it wrong. But if you say, hey, this is what 3 times 5 is equal to 15, this is how I get, that's my calculation, and I want you to show me how you calculate the numerical answer to this problem, and you force it to actually provide step-by-step reasoning, you may find that it is a vastly improved output. You get far better results. As I said, you can't trust the model. Effectively, ChatGPT has got one word, it's looking for the next word out of a massive database, which has got some shortcuts embedded in it, and it's looking for one word after another. So it's a large language model, and that's how it actually essentially works. So numerical stuff isn't that good. Now, I was laughing at a really simple example, which I thought quite amusing, actually, and I don't go through all the things. There's a particular Arduino model where you go on a little, you get the model, the little robot, to go on a line. So you draw a line on the floor, and then you want the little robot to go on this line on the floor. And it's actually amazing how powerful it is. You go to ChatGPT and you can say, hey, I want you to build a line following model using Arduino. So this is, and it'll say, what are the steps in building a line following robot in Arduino? It'll give you step by step every design feature for that model. So you can actually go through step by step, and it will tell you exactly what to do. And then you can even ask it to do your budgeting for you. You know, what's the components I use? It'll come up with a really powerful output. So it's a very simple example. And it continues. I'm not going to go through the individual steps because they're not of much interest, but it shows you how powerful it can be when it's pulling it up. So it actually produces all the details. And at the end, you can say, hey, I want the CPU on this model, and I want you to write the program for it as well. So it can actually write the program. And in fact, we use it quite a bit for when you're writing Python code, you can actually ask it for examples of the code and actually give you a particular example. But again, you need a programmer just to skim through to make sure that it is going the right way, because you can never trust ChatGPT. And you, the human, are always critical. You need checking all the time. So that's absolutely important. Anyone that thinks it's going to give you 100% accuracy is hopelessly disappointed. So here's a typical example for an engineering professional, the sort of typical solutions that it can give you. Answering technical questions. I've got a technical question, please give me an answer here. Simple explanation. So if you've got a complex problem, you can say, I don't understand this, please can you give it to me in simple English? You can actually come up with a really simple answer. It comes up with solutions to difficult problems and can help you with troubleshooting. And it ranges from plumbing, electrical tasks, all the way up to complex programming tasks. Project management can give you timelines, budgeting, career development, job opportunities, and suggestions and communication and collaborating with other people. There's another little extract here which I just want to give you before we engage in a particular problem with the computers. Just to revise it, and I've really gone through this, but I just took this on Business Insider. It's quite interesting. It says, first of all, assign a specific role to ChatGPT. So when you ask to do the problem, make sure you give a specific role. You are a top civil engineer working in the Western Cape, or you are a bridge design engineer in Africa. And then you say specific about the task. Give it a specific task. I want you, and the smaller, the more defined the task is, the more likely you're going to get a happy result. Be specific about the task. Don't give it lots of tasks. You may have to give it multiple tasks as you go through, but you do that one at a time. Fine tune the prompt. So when you get the result, you may not be happy with the result. Then you go back and you fine tune it. I was looking at an architect using Dell E, which I'll be using on this computer here, which is the graphical design tool. And you give text and it gives you a graphical output, and I'll demonstrate with some of your examples later. And you can see the iterations he goes through all the way through. Like it's about 10 iterations before he gets a reasonable picture of the house. It was a particular African house in a savanna environment. Provided with context, in other words, tell it what it is. I want a adobe mud built hut based in the savanna, and I want it in the blah, blah, blah. Avoid long prompts. Try and do it in small bites. You can also ask ChatGPT, how can I improve your prompts? And you can also, when you're doing this exercise, give it instructions to tell it what it should do for a graphical output as well, which I'll input into this computer here. It will come back a bit later. And then rephrase. So you're constantly rephrasing, iterating all the time when you're not happy with the results, because you as a human have to check the results, because you cannot be sure you will be getting the right output. And then use imperative or commands. Don't say, I want you to think about doing this. Say, do this. Be direct. Use short sentences. And then what's really useful, define what you want from ChatGPT. So if you don't know what you want, you're unlikely to get what you think you want. So be specific. I want this. I want 200 words on cabling my new switch box, which is based here in Midrand, and blah, blah, blah. So obviously, I'll give you some demonstrations of AI. Bear in mind that ChatGPT is problematic. As I said, you cannot be guaranteed the results. And in fact, one of the universities in the States, they've got a big problem, and this is what we're trying to work through at the moment, and that is that they're using ChatGPT to interact with their students, which is good. That's fantastic news. The problem is that it lies a lot. So what they've done now is they've got another model on top of it, which is very familiar with the course content. So electrical circuits 101 is this model, ChatGPT is below it. So this model is trying to check the output from the ChatGPT model and clean it up. So the solution to a lot of applications isn't very simple because it does cause some angst. Okay, now we're going to look at the case studies, and this is where Uncle Lamla comes into thing. As I said, we'll break up into 4 groups, and I think we've got some activity here. Hello, Edwina. Okay, so we've got the computer. So basically the case studies, I'm just going to run through them, and I want you to use ChatGPT to actually come up with some useful designs. So let's look at the designs first of all. Just bring them another 5 minutes. Yeah. Yeah. So the first one is water resources engineering project. So I'll go through them as four case studies, and just if you just go back to that one. Thanks. Thanks. Sorry. So you're a top water resources civil engineer, and you need to ask ChatGPT to help you with the following design problem: a borehole and water treatment plant in a remote part of South Africa for the provision of clean water for a community of 300 people. Consider the specifics and the constraints, and then critically assess the response from ChatGPT, because you've got 10 minutes to do a design, which will take weeks. So it's going to be fairly short, but still. And then make some suggestions once you've done that from the design. I want some words from you to feed into drawing a picture of what you've done. And again, using DALL-E, D-A-L-L-E, which is a accessory here, which you can put text in, and then it comes up with a nice picture. Generally, the picture's gibberish, so you've got to work on it. It's particularly for engineers, it's ultra gibberish, so you've got to work quite hard to get something sensible out of it. But it does come.
This section for all of them is the same, everybody.
Yeah.
This last section.
So we'll come. I'll just go through the other projects, and we'll come back to this when we assign the groups. So we'll assign a scribe from each group. You are a top bridge construction engineer. Ask ChatGPT to help you with the following design problem: a bridge across a river 30 meters wide for a remote community in South Africa using local materials. And again, you may find some challenges there because ChatGPT is probably biased towards sealed roads in America or something. But anyway, that's a problem for you to think. Next one. You're a top solar power designer. Ask ChatGPT to help you with the following design. This is a classical problem which we all have. Solar panel installation for 30 kilowatts for a building 2 floors high in Midrand with roof panels. So basically, I want to come up with a solar panel design, again, using ChatGPT. And the next one is, this is one of my favorites. You're a top road construction engineer. Ask ChatGPT to help you with the following design problem: relatively flat 15-kilometer road in the Cedarburg region of the Western Cape. It penetrates the mountain and uses local materials. So it's fairly flat, so there's no curvature issues. I'm not a civil engineer, so forgive me. The final one is you're an expert control and instrumentation engineer, and the design problem here is a pump station to pump seawater at the rate of 400 cubic meters per hour into a mineral processing plant off the coast of the Spergebied of Namibia. Detail the control and instrumentation strategy that will be required to control this pump station. So I want someone just to work out what the strategy is using ChatGPT. So those are the 5 problems. We've got 4 computers here, so we're going to allocate. I think we'll do 1, 2, 3, 1, 2, 3, 5 this time. So we'll break up into groups. Where are the computers? Where's our chum with the computers? So as I said, we want you to discuss in your own groups. Assign a chairman, chairwoman, preferably, chairwoman, and we've got an IT.
We're going to use 4. I'm going
Yep.
to.
So we'll break up into groups. So we'll have this group here. 1.
First 2 rows.
No, you have to 3 rows because you've got.
3 rows.
Yep.
We'll need to create 5.
Yeah, we don't have enough computers.
Oh, there's only 4.
Yeah, 4 lively computers.
Yeah.
Okay, so what you'll see on your computer, I just want to, again, if you're not familiar with it, let me just quickly show you on the computer. I'll just quickly go on that. Let me just show you. You should see something similar to this. Lamlo's done his best. You'll see a share application. So what you will see, and online, if you can all go to the OpenAI or watch what we come up with, you should see you can register with OpenAI. You can register with OpenAI. It doesn't cost anything. A very simple task. But those of you that are here in the classroom, you will see a screen looking like this, ChatGPT, and then you can enter a message. So we've set up these computers with it already set up. So you will enter the instructions into this area here, send a message. Like, for example, you will send something like, I'm not giving you the solution to the first one, but what you'll see is you're a top road construction engineer and are required to design a road in the Cedarburg, blah, 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 and then it'll come up with a whole lot of solutions there. And that's what we want you to come up with, and then to assess the output and say, this is complete rubbish, or hey, this is actually quite interesting. And then maybe even iterate further and say, put some more changes, changing this thing here, changing what you've entered again, because you have to be a human to get your maximum results from that. Change that text if you want to get a more thing. And then once you've done, I'll ask you to report to the whole group here. And I'll, again, apologize for all being packed into this nightmarish, tight little box, but you will then have a chair who will then report back. So that's, yep. Okay, so let's just go back to the.
How will they, the group outside, how will they see what they
No, so what I'm going to do is I will give the groups now. I'm just going to go to the groups now.
There's one person going outside, I'm sorry.
What is the online? They're actually asking how they're going to actually participate in this collaboration.
Okay, so what they do is they go to OpenAI, and you can register for ChatGPT there if you haven't already. Okay, let's go back to the slide.
So one of the groups is allowed to get on that. Sorry?
Let's go to. Go down, down, down. Down, down, down. Okay, so let's go around the groups.
Okay, so just let me just no, but for the online people, because we autism now, yeah. So I'm just going to let me list the topics down.
Okay. Okay, so
Are you sitting up in another classroom or you're just sitting here?
it's leaving here, it's fine.
Come around, just watch them. Can you start getting the seats?
We trust is going to present or is okay.
Just it's okay. Leave it, yeah, leave it. Thanks very much. Say we couldn't log her in. Yeah, thanks. Okay, Green, I'll go around and I'll assign the tasks to them. No, there's 4 groups. There's 4 computers. Are there? Okay.
Please, starting with you, so can you introduce yourself? Tell everybody where you work, what you do, something interesting about you, and then go around the circle.
Hi everyone, my name is Abdullah. And I'm
Yep, I'm going to go through. I'll give you the topics now. Sorry, can I just squeeze past you? Thanks, sorry. Thanks so much, guys. Okay, so I'm just going to give everyone your tasks. Okay, so your task is, and you've got. Okay, sorry, I'll just quickly give you a task, but please introduce yourself. Can you just remember your task? It's going to be, you're a top water resources civil engineer, and I want you to design a borehole, a water treatment plant in a remote part of South Africa for the provision of clean water for 300 people. 300 people, borehole, remote community, use ChatGPT, and see what you can come up from a design point of view. So give it instructions, and you will scribe in, type in the words here, type in the text there, and you guys will all drive it. So please finish off introducing yourselves, and then this gentleman here will be your scribe, and you will give him some useful input. 300 people, borehole, water treatment plant, remote part of South Africa, and then once you've done that, you will give us a presentation to the whole group using ChatGPT. It doesn't matter, you only got 10 minutes. It's challenging, but do the best you can. Okay. The next problem for you guys is you've got a scribe here. Hopefully someone's nominated as a scribe. I want you to think about being a top bridge construction engineer, a bridge across a river of 30 meters wide for a remote community in South Africa using local materials. Local materials, bridge, 30 meters, river. Okay, so if you can give a scribe, which means someone who types it in, and you'll see at the bottom there, thank you very much for being nominated. Okay, now you guys here are a top solar power designer. You're a top solar power designer. Ask ChatGPT a solar panel installation for 30 kilowatts, 2 floors high in Midrand with roof panels. So I want you to put a design together based on that using ChatGPT. As I said, you've only got 10 minutes, but do the best you can.
The printed copy of the question, we should have done that.
Yeah, I should have.
Can you just send the slides? Have you not got the slides? I've got them.
Look, okay, with you guys, here, you've got a computer there, you've got your scribe, and I want you are an expert control and instrumentation engineer. Excellent. So you're the top, the best in the world. That's as far as ChatGPT is concerned. It is the best in the world. And you want a pump station to pump seawater at the rate of 400 cubic meters per hour into a mineral processing plant. So you're taking seawater, pumping it into a plant in the sand dunes, but don't worry about that, and detail the control and instrumentation strategy. In other words, what do you do? That's the strategy. So a pump station pumps seawater at the rate of 400 cubic meters per hour into a mineral processing plant off the coast of the Spergebied. Don't worry about Spergebied. Just pumps it off the coast, so it's from the sea. And I want you to detail the control and instrumentation strategy. In other words, what do you need to do from a control and instrumentation point of view? So ask ChatGPT what it suggests. 400 cubic meters per hour, seawater, and start with design. You've only got minutes. Obviously, it could be a basic design. Okay, thanks, Britta, for that. Now, the guys, I'll just go on to the guys online. Online.
One comment from the I think this is really a good exercise to be done in a group and in a classroom. Hope something similar will be organized.
Yes, we will. Yeah, too. So yes, definitely. So I want you. Can you just give them the one that I want the group? Am I online still? Am I? Online, I would like you to try the. Online, I would like you to try the control and instrumentation problem, everyone, using ChatGPT. You log into OpenAI, and you can then hopefully come up with a solution in 10 minutes.
Sorry, do you have to start by telling it that you're top?
Yeah, that's right. So you say, first of all, you say you're a top water resource civil engineer, and then you say, I want to design, borehole and a water treatment plant for 300 people. And then once you've done that, you'll get stuff out of it. Then you say, you fix it, you iterate. But you've only got 10 minutes, so you can only do so much. So don't get too worried about it. Thanks so much. I must say we've got some fabulous examples coming up from ChatGPT, and I'm very grateful. Sorry. Just, you got this one here. Can you just go to the last one, Britta? Thanks. You guys are an expert control instrument. That's very clever. That's very, very, very clever. Hey, Edwina, the way they do it, no, what we do, it's simple, it's brainless. All we do is we photocopy it, you just take a camera shot. Yes, like these gentlemen here. Yeah. No, he's already captured it. Yeah. But these guys can see, if you want to capture your shot, you can take a picture, but thanks, Lamela, that's fun.
We have one already on instrumentation.
Really?
Yeah,
oh my God. Gee, really, already? That's quick. Gee, so we already got solutions pouring in already. This is amazing, absolutely amazing. Yeah, so use. Thanks very much, Lamla, for rising to the occasion there. A very challenging project, but hey, thanks. Thanks, Austin. Okay, another 5 minutes, everyone. 6 minutes. Sorry? A little bit, but we're running out of time. Quarter past 20 past 3. So another 6 or 7 minutes, guys. Are you coming up with anything sensible here? It's all gibberish. Oh yeah, that looks good. Brilliant. No, that's fine. That's great.
Now, it's going to be open-ended questions only, or
Open-ended. We'll go through each one of the solutions.
directly to the expert, because how many liters we need to supply to
Yes. And that's what you need to ask. Those are good questions, and that's what you need to ask ChatGPT as well. How many liters per person in the Pofada region, a rural community, and do they need cattle? I mean, there's 3,000 questions to ask, but this is the beginning, the exciting beginning.
Fire up.
Yeah. Yes, you do. It's a postgrad course. You can do it, no charge. Oh, do you? You can teach them. You can teach. No, it doesn't. Austin, you'd be brilliant. Yeah, we do. You can do that. We don't have master's data science, but in industrial automation. So we've got those topics in it. But so they're units. But you should do the course. Yeah, just say you want to do the course, and you could teach it. I told them. Where's just the only question on my mind is How do we? Oh no, we'll just get the groups to present. Okay, we've got another 3 minutes, and then we'll get everyone to. How are we doing here, guys? Coming up with something sensible? No, it's looking positive. Excellent. Excellent. What are we coming up here, guys? Something sensible?
Yeah, we are trying to make sense.
Excellent. That's good.
Then it comes to the logical,
That's good. That's good. Too much. Too many people, not enough space. Could have done it outside. But it was under construction. Very scary. Hello there, everyone. Oh, yeah. Okay, everyone online. What we're going to do online is we've already got some solutions coming through. So we will read out the solutions from our groups first of all, and then we will get your solutions as well from Tafiso here and Lebo. Have you got solutions there? Any comments?
Actually, there's one last comment from Jeremy saying, remember to consult with other experts such as mechanical engineers, environmental specialists to ensure the designs meet all necessary requirements.
Exactly.
Yeah.
That's very good. To around this side, yeah. Just got that on it. Yeah. They can move over there. They can stand over there. It's fine. I mean, they can sit over there as well. It's fine. It should be fine. It should be fine. Okay, guys, another minute, and then I want to get you guys to contribute back.
Just listen up, everybody. This group is coming back in already. We might not. This group, I'm going to ask you.
Just move across here.
Be like a circle and go down that wall a bit, please. Okay, so move down that to the floor so that you can still see the screen. Thank you so much.
Thanks so much, Britta. Okay, so what we're going to do now, just grab a seat wherever you can. Okay, so I'm sorry to push you a bit like this. We just got quite a bit we want to still cover. Okay. All I wanted to do was give you some flavor. Obviously, it is very amateurish to ask you to do a 10-week design in 10 minutes. But I just wanted to explore the opportunities with ChatGPT. So I want to ask the scribes or the guys, the chairs, chairwomen, chairmen from each group to give us a quick summary of their endeavor. And the way we're going to do it is just to give us a quick summary of what ChatGPT did for them, what they put in, what they got out, some of the issues, and a comment. Is this useful or is it complete bunkum? So that's what we want to do. We've already had a lot of online comments from our 100-odd guys online saying you need to make sure that your expert in your group, the design group, does actually have a look at the design coming out of this because you can't trust it. So obviously those are big issues. That's what Jeremy Lebo has just reported. But so the first one you want to look at is the, let's go to the first one. The first one you want to look at is the water resource engineering project. So obviously it's a fairly complex issue and there's a huge number of issues here. But I'd like that group, the outside group, a borehole water treatment plant, remote part of South Africa for the provision of clean water for a community of 300 people. I mean, obviously, as we started hearing, people are saying, well, how much water does a person use every day? Do they need to feed their livestock? You know, all those questions come up. So that's the sort of thing we want to talk about. So I want to consider the specifics and then let's look at the response from ChatGPT. So let's have our first group, A, Alpha. Okay, tell us. So you got 2 minutes. You can come and stand up here. Come and stand up. Give him a welcome clap. Thank you very much. Okay, so off to you. So here's a microphone. Can you just talk into the microphone?
Thank you. Oh, hi.
Okay, so
Testing,
so
testing.
what happened?
Oh, thanks very much. So yeah, we put some nuggets of questions here. So we wore a conscious head because most we realized that ChatGPT supposedly will respond under subconscious answers. So we considered tools first. For instance, our bowl, design bowl water treatment plant to cater for a rural remote place in South Africa. So assess water demand
So
was
assess water
another,
demand, how
yeah,
much
what's
we
another,
need.
yeah.
That wasn't in the spec at all.
Sure.
That's obviously important.
Or conduct a hydrological survey. Yeah,
Hydrological
maybe,
survey.
yeah, any pipelines running around under the earth or something. Bowl design, maybe how expensive is gonna be our bowl design or any vendor we can buy other than Jojo tanks. So yeah, other than that.
Okay, so now what you've done there You don't need to repeat the questions to ChatGPT. You can just simply, because you're in a chat session, so you're like chatting to an expert. Well, you hope he or she's an expert, and you're getting information back. So they are your best chum. They already know a lot of the stuff, so you don't need to repeat it. You can just add new information in. So you don't need to say, oh, they're not that stupid. Well,
So, yeah, then the ball depth calculated,
depth,
yeah, calculated to,
so when you
yeah,
put borehole depth equals 50 meters, you should say design for the borehole depth of 50 meters. So you
Yeah.
need to say, and I want you to give me the following information. So you've got to chat to it like you're chatting to a human with specific instructions. So by just saying 50 meters, it's not an instruction. And what do you want from ChatGPT?
So yeah, then I think then the meter of the ball then calculates maybe the specific vendor we can consider.
Yep.
Yeah, type of treatment plant design will also come from even the water, if it's gonna be storage, because okay, it was not specified if it's gonna be also substituting for sanitation or sustaining sanitation. Yeah, I think so. Yeah, the water is well. Yeah, like thank you very much.
Thank you. And what are you? What's your feeling? Is ChatGPT going to be useful or not? Is it complete rubbish?
I think we're still gonna use our conscious head every time.
So in essence, ChatGPT, you guys ask a huge number of really good questions there, but you need to specifically treat it like a human and say, hello, this is what I want from you, and this is the results. But you can see overwhelmingly, you still need to know what you're talking about, and you still need to check what comes back. Because it, get a professional engineer. I didn't say that. So I'd say get a professional engineer. It's obviously a bit. So there's no doubt that this will help us, but it's not the end game. But eventually, in 10 or 20 years' time, I do see it giving better and better results. But at the moment, it's a useful tool. So let's look at the next group. The next group is bridge construction engineering. You're a top bridge construction engineer. You want to construct a bridge across the river 30 meters for a remote community in South Africa using local materials. Thanks very much. Thanks so much for jumping in here, guys. Can you grab the microphone? What's your name?
Morris.
Morris. Okay, just hold it in chat.
No worries. Okay, so we first started off by giving it the basics of the instruction we had to use. So we the top bridge designer, and we gave it the first description of what it was. It came up with a long list, 9 list criteria, which says you have to have a look at. And it physically went through giving us specific requirements, giving examples of it or suggestions. And we had to quite go in and try get it to focus on giving you the design. And in no place did it actually give you a design. It wouldn't give you a parameter. No matter how many, we've tried specifically diving in on its points it gave us and telling it, all right, you asked for a site assessment, we're telling you this is what we saw. And just quickly trying addressing all the questions it had, all the suggestions or the issues it came up with. And it literally just kept on asking additional questions to that. So at no place did it actually come up with a point where you can say, we actually went down to saying, trying to squeeze it down to saying, giving it less recommendations then, see if it would then further go on there. And yeah, but we came up to a point where when it tells you, yes, okay, the selection you made, if we say it needs to use wooden materials, because it's a remote area, and you use cement for keeping for the bases on the end, and just using the typical strength of it, all of it needs the amount of people it needs to hold. It basically told us this would be a good recommendation for the bridge you're trying to build. So you still have to tell it, okay, fine, this is what we want to do, and then it only replied back, okay, this is a good recommendation, and it still went on further, giving further things we need to look at. So it didn't at no point really actually confirm what it confirmed in a little bit, but it still said, well, go look at this and this and this and this and this as well. So it's a good guide point. I would say it gives a nice backbone for you to try and get a broad picture of what you want, and then you have to go and fill each item up as it requires.
Well, thanks so much, Maurice. I think the other challenge, which I'm just looking at your scan stuff there, it can't zone in on local materials in the area because it doesn't have that information on the internet. So it's stuck. It doesn't know what to look for. So, you know, there's a lot of very specific things which it will have great difficulty doing. But thanks so much. Give our chum here. Thank you very much. Thanks so much. Okay, next group. Thanks. Yeah, take it home. Yeah, that's a good. Okay, so the third one is thanks, guys, for enduring yourselves here. I mean, obviously, it's quite one thing I can clearly see happening in the future is that we always think about engineering professionals as being mechanical, electrical, or civil, but you will find increasingly with these sort of tools, we become multidisciplinary. You actually need to have a review across the whole of engineering because it's changing all the time. And these tools can actually make you more multidisciplinary. So you're a top solar power designer, solar panel installation for 30 kilowatts, a building 2 floors high, Midrand with roof panels. And I'd just like to add, our Kerry has been, and Brenda have been putting panels on the roof here. South Africans are being ripped off to the nth degree for panels, just by the way, because we're doing a similar project in Perth, and the panels there are about 30–40% cheaper. And it's because everyone here is now jumping onto the bandwagon. So I just want to beg you, if you're buying panels, please make sure you check with reputable suppliers. Now I can give you some names of good suppliers now. Can you just give me that list? No, don't worry. Okay, so the solar energy panel design. Where's our team? Yeah, please come up and bare your chest. Thank you very much. Now, you would think that of all the problems, this one would be a lot easier to solve because this information is more freely available on the internet because everyone's putting this stuff out today, particularly here. Over to you. What's your name?
It's Roger.
Roger.
Yes.
Roger, welcome. Okay, give us your situation.
Thank you very much. Good day. My name is Roger. I'm not an electrician. I'm not a technician, but I'm going to try my best. Okay.
That's good. That's
all right. Yes. So we had, this was the topic. Yeah. I'm sure you can read. Excuse my English. I'm not that good. Come again. Oh, yeah. All right. All right. So we are to design a solar powered system. Yeah. So these are actually the factors which went into consideration. A 30 kilowatt. That's probably the size of the system. Yeah. And then 2 flows, and then so ChatGPT, so ChatGPT gave us points here. I'm gonna call her she. So she so she didn't give us specific details like details as an electrician, electrical engineer would do. So he gave us actually the backbone of the whole system. Oh, sorry, it's a she now. All right. So she spoke about roof orientation. So which means roof orientation and tilt. So this probably will be talking about the azimuth, where it's facing. I'm speaking the language now. So, all right. So on this one, he specified that here in the southern hemisphere, here in Midrand, that was the specific. Or she said that the tilt angle. So the tilt, they mean when the roof is like this. This is steepness. It's at 25.9 degrees, which is perfect for efficiency. And then point number 2, he spoke about the space. She did not give us exactly how much size we need since the 30 years, but we have to actually calculate for assuming that we've got 450 watt solar panels, how big is one panel times the number which can satisfy 30 kilowatts. So she did not give us those specifics. We had to calculate. We are good in maths. All right. Number 3, Yeah, exactly. She speaks about solar panel.
Selection.
Yes, the choice of solar panels depends on the factors like efficiency, durability, and cost, like Say was talking about here. So we did our research. At the back, they've got a very good group. We spoke about what we call monocrystalline. Have you ever heard about it? Yeah, so it's a type of solar panel which is very efficient. Yes. And then the brands, I'm not going to name, I don't want to be arrested. But yes, but actually the point here, she's actually giving us the effect that there are some other brands which are not good. Yes, so keep in mind about that when we design your system. All right, and then she speaks here about the inverter selection. Some inverters are for people just to like for 3 months and then it's, you see, and some inverters are very good. That's according to what we found out here. She picked that. Actually, we gave her the answer. It's a 30 kilowatt hour inverter. But now we thought about something which happens. It could be hard to get a 30 kilowatt hour inverter as a component as one in the industry. So there is something which they call paralleling. Yes, which means it's going to be two of them, which can add up to 30 kilowatts. Guys, I'm very good, eh? All right, and then on the mounting system, just like any other commodities, there are always fake stuff, there is always original stuff. So she's telling us that it's always good to have reliable mounting systems. So we're talking about the hooks, roof hooks, which goes into tiles or whatever the kind of roof you got. And then the rails, the kind of bolting, and it goes also to who is going to install. If I install, it's going to be good, guys. And then yes, and then she speaks about the monitoring system. This is very good now. I think this is technological, considering integration monitoring system and track performance. So also there's something called, back to the inverter, there's something which they're saying MPPT. Yeah, this one is good. Don't worry, I'm going to tell you what it is. So they say it's maximum power point tracking. So they are saying with MPPT, what happens is a smart inverter, a reliable inverter, is able to detect where it's getting the most power output, and then it utilizes. So let's take, for instance, we don't have space in one side, but now we've got panels this side and this side. It's 12 o'clock and we don't have power, we don't have sunlight from this side. So a good inverter will always draw the best from the side which is exposed to the sunlight. Am I clear? Yeah, you can tell. All right, yes. So the last point which ChatGPT here gave us here is probably the most important one. So she says it's important to note that for comprehensive and accurate design, it's recommended to consult a professional solar installer. We can assess this fact. So on our side, we thank you so much for the time. Thank you, sir. Thank you.
Roger, thank you very much. I must confess, Roger, you're in the wrong business. I'd say Mr. Noah, Trev, let's call him Trev in New York would welcome you joining his little act, because I think you've done a brilliant job. So look, just bear in mind, I know everyone's a bit critical about ChatGPT, and I can see very clearly why. But just bear in mind that the questions you're asking are very, very high level questions. To get the specific gems, you need to drill right down. So you would break those issues that you've got there into smaller nuggets, if I can steal someone's magic word earlier on, nuggets, and you would then drill down as you gradually penetrate to the bottom. And so you're only scraping the surface at the moment. So you probably will find better results as you drill down, but you still need to be critical about what you're getting. So, but thanks, that was a very, very good presentation. The next one, the last one is a very difficult one. Can you just go to the last one, Britta? Thanks. Just control instrumentation design. So this one's a very traumatic type of one. I love control. So we've got a pump station to pump seawater at a rate of 400 cubic meters per hour into a mineral processing plant, diamond plant, that so happens. And you want to know the control instrumentation strategy. So basically, you've decided you need to do this, And rather than spend hours and hours and hours, you go to ChatGPT and say, hey, sister, please give me some insight. So who do we have here? Hezron. Hezron, thank you very much. Over to you.
Yeah, thank you so much. Okay, so this question basically, you need to get like a control philosophy. You're basically looking at the most important parameter there is the flow rate that you need to really focus on. So with regards to flow rate, you need to consider also the pump sizing, flow measurement, and your whole level control when you're pumping into the mineral processing plant. So it goes with all calculation for pump size, pipe sizing. So after asking ChatGPT, gave us like suggestion just to power your pump. Then also it went on to give us flow flow measurement in terms of the type of flow meters that meant for this paper. The level control system will be implemented to manage the desired seawater level in a storage tank or sump. But it just gives you like a basic suggestion as to.
So it says flow meter can be ultrasonic electromagnetic. So obviously you don't want that. You want, I'll make what is the best for this application.
Yeah, so it also goes on to gives you, because for every plant or processing scenario, you need to look at safety interlocks or safety measurement, which is one of the critical things that are really looked at when running a processing plant. So it suggested safety interlocks will be implemented to protect the system from any abnormal conditions. Then obviously, you also need monitoring of how your system is operating. So it gave us also a suggestion for using like using DCS or programmable logic controllers, like for centralized monitoring, see everything like from a greater perspective. Then we just dragged in a little bit just to find out any suggestions with regards to the pumps that could be used for seawater, because seawater is corrosive. So we need to have specific types of pumps for this type of application. You can't just use any. Then it gives centrifugal pumps, submersible pumps, and a whole lot of other information here. So what we also did was to try to find the size of VFDs that can be used for pumping the seawater through the pipeline, because you're looking at a situation where you also need to monitor if your flow drops, there need to be feedback for the pump to go up. If it's too much, they also need to send a feedback to drop the flow. So regarding the determination of the pump size, it just told us find out the power rating of the motor driving the pump, typically measured in kilowatts. Then you also need to look at motor efficiency, and also you need to consider the load type and the duty cycle of the pump. So that's more or less what it gave us in terms of the pump system, and also the type of drives that you need to use, because those are mostly like the critical parts. In terms of where we're pumping to, obviously there's going to be things like your tanks. You need to have also a good measurement for the tanks. There's also going to be a lot of things like valves. You need also to do a valve calculation for the correct valve sizes for this system. But typically it gives a suggestion. But as a control engineer, instrumentation engineer, you also need to look at this and remove what's not necessary and consider what you think you can implement.
Thanks very much. Thank you very much, Hezron. Brilliant. Thank you so much. That's brilliant. And I mean, some of the stuff there is pretty good, like oversize your VFD, your variable frequency drive for the pump size. You know, those are all reminders to you, and they're all useful pointers. So it's interesting. And again, to get the maximum bang for your buck, you've got to drill right down to specific questions which you as an engineering professional would be aware of. But still, that's really good. So yeah, I mean, this is unfortunately time's tight. So I just want to do a summary of this, and then I just want to point out another tool which I can see growing increasingly in importance. And it's obviously taking text and converting that into a picture. And that's also really, really important for showing your team what's going on with the design. So that's also another important tool, which is basic now, but those of you that have played around with them can see would be seeing some pretty good results. So I'm just going to quickly share my screen in a minute. There's two tools out there. There's two tools out there, and the two fairly popular tools are DAL-E and what they call Mid-Journey. Sounds like midstream, which we know what that refers to. And the Mid is probably more designed for artistic stuff, and the DAL-E, which is linked up with ChatGPT, focuses more on sort of, it's close to the engineering schematic type stuff, but it's still very, very primitive for engineering. But SolidWorks already are starting to move into the space with stuff. So for example, we can type in there, and unfortunately you've got to pay for these nowadays, but they're not too expensive. But let's say it's a bridge of 40 meters in the Peru in a bright sunset with low-level bush. So generate, click, and you'll see it comes up with some very strange things. Don't forget, it's not, that's just some advertising. It'll come up with the, so it's working out, and it's come up with hopefully 4 pictures. They don't come up on the screen yet, but let's take oh, there we are, okay. So there it's come up with some suggestions there. So you've got 4 things. So what you do, you can already see the sunset, the bridge, the distance. It's already coming good. So then basically what you do is you would then take that design. So let's just take this one, for example, and then you can do variations on it. So it'll come up with variations, or you can then say, hey, I'm going to do some instructions to it. I want to change the length of the bridge, the type of road on the bridge. You can then add all that into it very easily, very effectively. So this is just variation. This is just random variation. So, but you can see it's still keeping the sunset, but you've got different bridges there. So you can then take a bridge. Let's take that one there, and you can then edit it. So let's say, for example, we're going to edit this section there. Add in railings to bridge. It's a bit random, of course, so, but you can then, or change the, or you can rub this out, you can erase it, I'll show you that now, but you can then change the layout, and you can actually come up with some really interesting designs. And you can see that this sort of technology is going to dramatically improve, because it's designed for an absolute idiot. So obviously you can see here there's a bit of a problem. The railing's gone that way, and you obviously want it to go that way. So it's because I've chopped the rail in half here, so it thinks there's another stitch there. But you can then do various tricks. You can go and rub out the, yes, no. So we can accept, sorry, I should accept, I forget about that. So we can then rub out the road and say gravel road. And then of course you get a, what it comes up with. And I should have moved that across to the middle. So, yeah, so it'll come with the gravel road for that right there. Yeah, there's a bit of a change to the road there. So it's sort of fixed. So you've got to move that frame across. But anyway, you can see that there's a lot of opportunities with this. The mid-journey one is the one if you're smoking lots of dope and you want to think about things in the cloud, you probably go for mid-journey. But if you want to do some real more concise designs, probably LE is the one to go for. Ignore my sense of humor. It's a bit deranged best of times, so stop sharing. So yeah. No. Just going back. Okay, if you can go back to the things again, Britta. Sorry about that. Okay, so just to conclude, I just want to go through a few final comments. I'll get the slide. Sorry to throw you around with that. I mean, obviously, everyone here jumped in with great enthusiasm. So the one issue which I find quite interesting is that it's quite easy to get upskilled with these tools. It's not like a long journey of pain and suffering, but obviously you still need to have a huge technical insight, and you need to be very patient and meticulous as engineering professionals to drill down to ask specific questions. So, oh, sorry, sorry. And